Hey everyone, so today we're going to be starting our functions unit. We're going to be looking at function notation and how to read functions, and then we'll be evaluating functions. So let's take a look. Okay, function notation. Function notation is the way a function is written. It is an efficient and effective way to display functions of all types in math. The most popular function notation it looks like this: f, open parentheses, x, close parentheses. This f can change. It could be any letter, but the most common one that we're going to see is f. And the way we read this is f of x. So we would read this f of x. So not f times x, not f parentheses x, f of x. Okay, so the following function reads f of x equals 3x plus 1. That's how we would read this. Remember, we are not multiplying f and x. F is just the name of the function. It doesn't represent a variable here. It's not representing anything unknown. We're not trying to solve for f. It's just the name of the function. So the x value, which is in the parentheses, is always our input value. So whatever number is in this set of parentheses here is going to be our input value. And then this whole thing is equal to the output value. And when we evaluate functions, you'll have a better idea of what that really means. And just so you know, f of x is the same as saying y. So f of x equals is the same as y equals. It's just a fancy way of saying it. It's just function notation. But we could easily write this as y equals 3x plus 1, and it represents the same thing. Okay, so here we're given this function, f of x equals 3x plus 4, and we want to find f of 3. So these are the two steps that we're going to follow whenever we're evaluating any kind of function. We're going to substitute the input value inside the parentheses. So that's this little 3 here. And we're going to input that wherever we see an x in the output value. Then from there, we're going to use the correct order of operations to simplify. So I'm going to show you exactly what that means here. So we have f of 3. So I'm going to just write f of 3 is equal to, and then like I said, wherever we see an x, we're going to put a 3 in parentheses. So 3, it would be 3x. So instead of 3x, we're going to write 3 parentheses 3 plus 4. Basically, what this is saying here is x is equal to 3. So we're taking that 3 and substituting it in for x. Now from here, we're just going to use the order of operations and only focus on this side. We're going to leave this f of 3 alone. Don't touch that. And we're going to simplify this output here. So I'm going to multiply 3 times 3. That gives us 9 plus 4. And then 9 plus 4 gives us 13. So that means f of 3 is equal to 13. So that means our input is 3, so our x value is 3, and that means our y value would be 13, because remember, f of x is just the same as saying y. So if our input is 3, that means our output is going to be 13. Okay, and remember we're using order of operations here. That's why I did the multiplication first and then added. Okay, let's take a look at another example. Here we have given f of x equals negative 2x minus 6. Find f of negative 4. So if it helps you, you can just say, okay, that means x is going to equal negative 4. And wherever I see an x, I'm going to plug in negative 4 in parentheses. So we have f of negative 4 equals, instead of negative 2 times x, we're going to have negative 2 times negative 4. Just substituting that negative 4 wherever I see an x, minus 6. Now we're going to simplify order of operations. We're going to multiply first. Negative 2 times negative 4 gives us a positive 8. Bring down your minus 6. 8 minus 6 is 2. So that means f of negative 4 is equal to 2. So if our input is negative 4, that means our output is 2.